Hello, in this video I will show you how to simulate effect of ion channeling of implanted particles inside some material using Monte Carlo code SDTrimSP. So basically I will illustrate how to obtain such distributions as these, which are from ion implantation of nitrogen into different surface orientations of vanadium. So you can see as for illustration like how the surface orientations and the open channels can look like here. And yeah, so let's get right into it. And first of all, you need to have the SDTrimSP code, and I made previously a tutorial how to compile it and also how to run simulations with corresponding graphical user interface for this application. So you can find it in the video if you write into YouTube this caption, and I will also put it into the description of this new video. So now I will suppose you have installed correctly the SDTrimSP, and let's get into the preparation of the necessary input file which will perform the simulation of ion implantation into the crystalline phase. And another important note is that you need to have version, I think from 7.0 for SDTrimSP, where is the implantation into a crystal implemented, and older version it's not available, and also for this reason it's not available in the graphical user interface. So let's start it with the input file preparation. I will still use the graphical user interface to prepare the main parameters of the implantation, and then I will add to the script like just 2 more lines which will define implantation into crystal. So let's say I'll go here to this example, and for instance we will simulate the same profiles as I show you. So implantation of nitrogen into vanadium, and we can use the like these parameters for the implantation. So this model for the nuclear stopping, and for instance this model for the electron stopping. And yeah, these parameters I will keep on the predetermined values. And just to be quickly finish for the illustration with the calculation, I will keep the statistic of the total number of implanted ions at a small value. Okay, so these settings here I will use now. So here I need to preview the file and copy all its content into the folder where I will perform the simulation. So let me open the folders, and I prepared here three folders as an example. Let's start with the 110 orientation, and just to show it from the beginning I will remove all what I previously tested, and now I'm in the console inside the same folder as it is here, and I will create the SDTrimSP input file. And okay, I'm here. I am in different folders. Sorry, I need to go to 110, which is empty, and now I will create this file and copy all the content here. And what I need to add to simulate into the crystal instead of a static amorphous target are just these two lines. So this first line basically it's saying to the program to perform the simulation into crystal, and then these define the Miller indices of the surface orientation. So in my case I'm in folder 110, so let's simulate correctly into 110 surface orientation of vanadium. And now I can save it and exit. And a second necessary file for the crystal for the simulation into the crystal is the face itself. So I need to have the BCC vanadium phase input file, which is in SDTrimSP-specific format. So what I would need to do is to create this format correctly according to documentation, or I did a tool which is available online on this link, and here you can upload your crystal file, which can be either in a postcard or in SIF, and it will automatically perform the conversion into the SDTrimSP specific format. Okay, so let's illustrate it. I have here the vanadium in postcard, and you can easily obtain it from database such as Crystallography Open Database or MC3D database or the Materials Project, or actually you can use my aggregator as well if you want, just for a quick illustration. Okay, let's not go into it. Well, you can easily obtain it from the databases, and okay, actually let me show it too. So I will go to the to this link, and here I have the aggregator for or 3 databases, and I can just search for vanadium, for all phases with vanadium, and then I will download the phase that I want and upload it into this converter. So it found me some phases, so what I need is the BCC phase, which I can then download, so any of these are fine. Okay, so let's go back into this, and I will put a postcard file here. Sorry, I need to select I need to select this converter tool first, this option, and now I can upload the file, and you can see it automatically converted me the postcard into this specific crystal inp file. And 2 notes. One is that this file, or the program currently in this version 7.01 that I have, supports structure which has only up to 16 atoms. So this you have to keep in mind. And also the program internally converts the uploaded, like the structure from this file, into a supercell, and this is supported either as 3x3x3, or it can be as 5x5x5, and it's defined by this parameter. If you need to know some other specific parameters, you can go to the official SDTrimSP documentation, and it's mentioned there. These are like the main one for me now. So of course 5x5x5 will take more time to calculate, so I will just keep now 3x3x3, and now I can just copy this content and download the file here, and need to create this crystal inp in the same folder. Okay, so now I have these 2 files, and now I can run the simulation. So basically I will use 6 cores, for example, and here you can see it started to run correctly, and it will be updated into the console every 10 after 10%. And with this small statistic, the small number of set ions, it's pretty quick, so I can just wait until it will finish, and then I will show you how to easily and quickly plot these profiles without like going into the specific output file. also in this application. Okay, so it's done. Let's go to this folder, and the file that I need, for example, is this one, which contains the depth distribution of implanted ions. And instead of like copying the values from here to obtain the profile, what I can do is simply to select the static mode here and put the output file, this one, into this uploader. I will just rename it to know it's from 110 orientation 110, or let's call it directly just 110, and I can put it here, and you can see it automatically loaded me the data. So you can also immediately see that this statistic is very low, but for the just to visualize the channeling effect and the difference between different orientations, it's enough. And in this tool I can also convert it. I can convert the units on the y-axis to scale it for some specific fluence, to have the units in ions per cubic centimeter. And the depth I can change also, either have it as angstrom or as nanometers. Okay, so now let's obtain another orientation, and to do it quickly I will copy these two input files. Okay, and delete everything here, and what I need to change is just one value. Sorry, not I need to change here the Miller indices to 1 1 1. That's it, and now I can run it. And also I will quickly prepare it already for the third orientation. Let's delete this, and I'll modify this. So what was this folder? 210. No. Okay, and that was very quick. So let's go to this last one and run it now also. And let's plot this second surface orientation of 110 to see the difference. So this file is 111 now, and I just put it here, and yeah, it automatically loads the profile, and you can immediately determine the significant influence of the channeling of the depth distribution for this 111 orientation. Just for the comparison, let's also upload here for the third profile once it's finished. Another thing I can plot is actually the concentration of vacancies for the target of the material. So I will just change it here to vacancies. Okay, maybe not. There's some problem. So okay, let's not go into it. Let's just stick with the implanted particle, and let's upload the third profile. And yeah, you can see that the channeling effect is even much lower than in the previous two orientations. So yeah, and then if I need to get these data directly as two column file, which I can then very easily plot and process in some other software. I can do it also here. Just check this option and then you can download the specific file, like the specific orientation that you want. Okay, so yeah, I think that's all uh, how to show you how to perform the calculation of ion channeling effect with SDTrimSP, and then how to easily plot the results uh, in this interactive application interface. Yeah, so thank you for your attention, and I hope this tutorial will be useful to you.